This first robotics competition strategy video is provided courtesy of Team 1701, the RoboCubs, from the University of Detroit Jesuit High School and Academy. I'm Mike Vinarsik, a Senior Lead Systems Engineer with Booz Allen Hamilton, a First Strategic Partner. I'm also an Adjunct Professor at the University of Detroit Mercy and a mentor for the RoboCubs since 2015. I've created the Systems Architecture Guild YouTube channel that you're currently watching to promote the best practices in system modeling and architecture and to advance the practice of systems engineering. There's a companion website at showmethewow.com. In this session, we'll cover some basic concepts related to FIRST robotics strategy and watch some videos about a successful robot designer and see how he applied those principles to win $500,000 from NASA. First of all, what is a system? It's a collection of parts and components, as well as the interactions and interdependencies and interfaces between them. The function of a system is greater than the sum of the functions of the individual parts. 1 plus 1 equals 3 because 1 plus 1 plus the interfaces equals 3. Without those interactions and interfaces, we just have a box of parts that doesn't do anything useful. Can you name some systems? Name a system from each of these categories: transportation, electronic consumer product, business, and robotics. How to succeed? Well, first of all, the first step in winning is not failing. And the first step in not failing is to understand what the problem really is, to frame it properly and establish the boundaries. Some of that's been done for you by the first requirements and rules, but you also need to do that as part of your team effort as well. You also need to consider the Zeroth Law of engineering, that any project has to be achievable by the project team with the skills and resources they have in the time available. Don't overcomplicate the solution you pick because you need to build it before the competition starts. Never forget that. In 101 Things I Learned in Engineering School, a great little book, there are several key principles that apply to FIRST. Number 3, the heart of engineering isn't calculation, it's problem solving. Remember, anyone can crunch numbers or solve a formula. The real art is setting the problem up for solution in the first place. And number 6, inside every large problem is a small problem struggling to get out. In general, most really big problems can be boiled down to a really simple solution or a simple problem to solve. And once that's taken care of, the bigger problem takes care of itself. And finally, number 97, the most important thing is to keep the most important thing the most important thing. Easier said than done. Try to keep a laser-like focus to keep your team on task, solving the right issues, and that's how you can improve your odds of winning. Now let's step back for a second and talk about systems architecture. It's the mapping of function to form via concept. That's a definition put forth by these professors at MIT. I happen to like it a lot, and basically it means you have to translate what something has to do into the design that's going to do it by selecting how you're going to have it execute that function. So let's look at a couple examples when it comes to writing instruments. So if our function is to make a mark on paper, we can have a pencil or a pen. For a pencil, the concept is to wear away a graphite rod via friction with the paper. In your variations, you can have mechanical or wood pencils, but again, the function is executed by that concept. In the case of a pen, you're dispensing ink, and you can have a quill, a fountain, a ballpoint, a roller ball. You can even consider some forms of felt tip marker in this category. You're dispensing ink with different mechanisms. But again, the same function, making a mark on the paper, executed by different forms. And as you think about the first problem posed to you, there'll be certain functions you have to do, and the forms you choose to do them will dictate the design of your robot and how easy it is to fabricate and operate. Some of the typical FIRST robotics functions, and these are courtesy of Jerry Kempf, a mentor that we had in 2016 with the RoboCubs: collect the game piece, control the game piece, align the game piece, deposit the game piece, typically for scoring, and move. And I think if you look back at most FIRST robotics challenges, you'll see that all the robots execute some combination of these functions. So your goal: you don't want to build the best robot possible. Nobody has that much time and money. But you do want to build the best robot that you can to win the competition by not being disqualified. Again, don't lose instantly, so pay very close attention to rules that will get you disqualified. And then your robot has to do its job better than the other robots. So what is your robot's job? It has one job: to convert time into points. Time is the primary currency that you're going to be spending. And then game pieces, of course, are typically the other. But how your robot spends these two commodities will determine how well you do. Everybody gets the same number of seconds in this match. It's how you spend them will determine how well you do and how many points you earn. So for our case study, we're going to look at the Moonraker, a robot built by Paul Ventimiglia and his team. And if you watch BattleBots, he should look familiar because he's competed in both seasons and done quite well. So these videos and slides are from a case study done several years ago by Jonathan Weaver and myself at the University of Detroit Mercy, and they're available at the website below. So with that, we'll go ahead and watch the introductory video.